In today's lesson, we are going to be looking at scatterplots and linear regressions. So just some things to recall, just some definitions, because we are going to be kind of incorporating again the finance into this data lesson. So assets are an item that you own that have value. Appreciation is the increase in value of an investment or asset, and depreciation is the decrease in value of something over time. So we're going to be looking at appreciation and depreciation when we create our scatter plots. Right, so where do we see appreciation and depreciation? Again, just to review, value in a car over time, right? That's depreciation, that's going down. Right? The value of a house over time, in most cases, the value of a house appreciates, it increases in value, right? Especially when the housing market goes up. Connor McDavid rookie card in 20 years. You could argue one or the other, but in most cases, when things or items that are rare get older, they tend to increase in value. Right, so a McDavid rookie card. If you don't know hockey, one of the could argue that he's one of the is one of the current best players in the world for hockey. So his rookie card, the first year he was a professional, tends to be rare. So appreciation. Value of an iPhone 14 in 10 years, right? Phones depreciate in value. In 10 years, we're probably going to be on the iPhone 24. Right? So it's not going to, the iPhone 14 is probably not going to be worth anything if it even works. So when graphing appreciation and depreciation, we can use that, or it's used to compare the relationship between two variables when we look at appreciation and depreciation. And then the two variables we're going to be looking at are value and time, right? What is the value of the item and what is happening in the years or over time, how many years, right? So we're just trying to see, is there a relationship? What is happening to the value over time? Is it increasing? Is it decreasing, right? Appreciation, depreciation. And when we're looking at two things like that, it's considered kind of a two variable relationship, right? We're looking at two variables. We're not looking at one thing, we're looking at two. And when we look at two variable relationships, it could be something like value and time, but it could be other things, right? We could be looking at the height of a person versus their foot length. Does one affect the other, right? Looking at the age of a tree and the diameter, right? As the tree grows older, does the diameter increase or decrease? A student's mark in math and a student's mark in science, right? If they're strong in math, are they also strong in science? Or if they're strong in math, are they bad in science? The size of an engine or a car's engine and the fuel consumption, the payroll of a sports team and their winning percentage, time spent studying for their test and the mark on the test. Right? So two variables or a two variable relationship is when we're collecting two values associated with one or with a single person or thing. And what we're looking for really is we're looking to see, is there a correlation? Right? Do we notice a trend or a pattern when graphed? Right? So again, does the value decrease over time? Does it increase? Right? Does the winning percentage of a sports team increase when the payroll increases? Right? When we spend more money on players, does our winning percentage go up? Right? We're looking for these correlations. We're looking to see if there's a trend or a pattern. And when we're looking at two variable data, we're going to be looking at or using a scatter plot. And scatter plots show x, y coordinates for two variables. Don't forget, every point is an x and y coordinate. And the pattern that we see of the multiple points gives us a correlation, right? So if we see a pattern, if we see a trend, right, if we see a common thing that's happening to our points. Right, so the scatter plot below shows the relationship between average daily time spent doing homework and time on electronics, such as TV, phone, video games, among a group of high school students. So each point represents two values associated with one individual. So if we look at one person, let's look at this one right here because this is an easy one. Right, so it's 20 minutes. X value is 20, so 20 minutes of homework. And the Y value is 150 minutes of electronics. Right, so that is for one individual. They spend 20 minutes on homework and they spend 150 minutes on electronics. Now, does there appear to be a relationship between the two variables? Do we see a trend? Do we see a common thing that's happening? If so, describe it. I would argue yes, we do see a trend. As the homework increases, the time spent on electronics decreases. Now, you might argue, well, why is it not the other way around? And that's because the homework is on the x-axis. It's on the horizontal axis. So that's what we're referring to first. What happens when we change the homework or time spent doing homework? Well, as homework increases, time spent on electronics decreases. Now you could change it. You could flip it and put electronics, those values on as the x, and the homework values as the y. You would have to change your points around, right? Because you'd be changing the coordinates up. You'd get a similar graph, and you'd say as the time spent on electronics increases, the time spent on homework decreases. Right? So you kind of get a vice versa effect or an inverse effect. Right? But the idea is you're just reading through it. Do we see a pattern? We kind of see that pattern again. If we can't quite see it, most of the data is heading in this downward direction, right? So that's why we say as the homework increases, the time spent on electronics decreases. Now, what I did to kind of show that trend was I drew a line to kind of represent where the data was going. And so if there is a correlation, or if we think there's a relationship between the variables, similar to what we just saw, we can draw a line of best fit to represent the relationship, right? So it gives us an idea of what is happening. Right? We might also call that a trend line or a linear regression. Now, the line of best fit, it should have the same direction and steepness as the trend as much as possible. And you want to try to minimize the distance between any point and the line. So that's if you're drawing it by hand, which we are going to do. Now, which of the following examples do you think is the best fit? If it helps, maybe we'll put the data in, we'll highlight it in a nice, highlight the points in a nice kind of brighter value so we can easily see it. So does that black line or that horizontal line, that line of best fit, does that best represent the data? Is that a good fit? Right? And I would argue no. It doesn't really follow the trend. The trend should be increasing. Right? Yes, it's going through 2 points, but all the other points are kind of far away. So we could do better. The next one, it is better because we look at our trend, right? Same points. But we can see that the line is actually going upwards, right? So it is going upwards. So it is following the trend now. It's just a bit too high, right? It's not kind of close to the points. We have points that all the points are relatively far away from the line. What about the third one? Plot the points again, looking at it, right? We might say, okay, this is a lot better. It's now going through some of the points. It is following the trend. Right? It is following the trend. However, if I look at the points tend to be going more in this type of direction, whereas my line is headed this direction. So it's a little bit too steep for my data. So I'm going to say no, it's not a good fit. Lastly, right, let's color in these points to see it a little bit easier. I would say this is a good fit, right? If we look at our line, it's going mostly through some of our points. All the points are really close to it. So in this case, I would say yes, this is a good fit. And if we're putting a scale, right, I would say this is 1 for first, then second, then third, and then fourth in terms of how good it is. Right? So this one's following the trend. It's close to the points. as possible. Right? So that is why the far right is the best option. What we want to do now is draw a line of best fit for each scatter plot. So, for example, I might say, in your notes, you can try doing the same thing. I would say that might be a good line of best fit. The next one, this one's a little bit tougher. Say I draw something like that, right? Close to a couple points. Right? We have 2 above, 4 below, so maybe I could have moved it down a little bit. Right? You don't have to actually be touching any points. It'd be nice if you could, but you don't actually have to be touching points. It's not a connect the dot. You're not trying to draw in all the lines. You're just trying to draw a line that it goes through or as close to as many points as possible. So I'd say that's pretty good. You might have something different. That's okay. We'll talk about that in a second. And last one, again, right, as best as possible. I'm kind of just doing it quickly, but I'd say that might be a good line of best fit, right? Again, it's following the trend, it's following the direction that the data is going in, and it's as close to as many points as possible. Now, if you go back and you look at all 3 of those examples, do you have the exact same line that I drew? If you're doing this on your own, do you have the exact same line that I do? Do you have the exact same line that your friend would have? You might be close. You might be close to what we have, right, and what I drew, very similar, right? But is it going to be the exact same? And the question and the answer is probably not. Right? You might have the same idea, same trend, same kind of direction, but it might be a little bit steeper, or maybe it goes through a different point. Right? It should do relatively close to the same, right, if we're trying to do it correctly, but it's not going to be the exact same, or if it is the exact same, that's a good coincidence. So because when we're drawing it by hand, it doesn't always give us the same line of best fit, we can use what is called regressions. Right? And regressions is basically using technology to create regression models. Right? Lines or curves of best fit for any given data set. Right? So it doesn't matter what data set we're using, we can always create a line of best fit or a regression. And to look at how well the line fits the data, how well does the line represent the data, we look at what is called the correlation coefficient. And don't worry, you don't have to use any do any calculations. We are basically going to be using Excel or Google Sheets to do this for us. So how well does a line or curve fits? We look at the R values. And the R value is a number from -1 to 1 that gives the strength and direction of variables and how closely it fits between or models a linear relationship. Right, so it goes from -1 to 1. It's a measure of how well the line of best fit fits the data, how consistent the data is. The closer the number is to 1 or -1, the stronger the relationship is. And usually we calculate it by taking the square root of the R squared value. So we talked about it being from -1 to 1, right? Talking about the direction and the strength. So if I look at this kind of graphic, we can see at -1 is a very strong relationship. It's forming a straight line and it's going down or negative. Next one is kind of moderate, right? We do kind of see the trend. They're going close together, but they're not all in a straight line. But we do see a typical linear pattern. And it is going down. Right? Next one, it is increasing, right? Not very close together, or it is relatively close together, but not forming a directly straight line. So again, this would be in a moderate positive correlation. And lastly, again, we see going on a straight line, straight up. Right, so that's a positive linear correlation. Keep in mind the different terms, weak, moderate, and strong. That could be the same for whether it's a positive or a negative. right? So weak is anywhere between 0 and 0.33, whether it's plus or minus. Moderate is from 0.33 to 0.67, and strong is from 0.67 to 1. So all it is it's giving us a measurement or value of how close to a linear model does the data fit. So let's go through and let's work on creating lines of regression using Google Sheets. So you're going to want to have access to Google Sheets. Right? So you can sign in with your student account or just open up whatever account you use in Google, open up a Google Sheet. And you're going to then enter your data using two columns, right? An X and a Y to plot points. You're going to highlight all the data, insert then the chart. And from the scatter plot or from the chart editor, you're going to select a scatter plot. And then we're going to go through some customized options. And again, I'll walk through all of these with an example. Right? But you're going to basically click on the series button, check off trend line, select label, use equation, and then check off the box that says R squared value. So basically it allows you to basically do all those calculations for you. So let's look at appreciation. Right? We're going to look at appreciation. We're going to look at two things, time and value. Right? As time increases, does the value increase? So we have our table of information here. So we want to go to Google Sheets, which I've already brought up over here. We're going to have two columns. We're going to have our year, and we're going to have our value in billions. So we don't have to use the actual billions with all the values. I'm going to say that the year 2013 is equal to 0. So that's going to be our year 0. That makes it a little bit easier so that we're not having a graph that starts far off because we're starting at, let's say, an X value of 200 or 2013. So I'm going to put in my years 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, might be 10 values. I'm going to enter in my data. Again, this is right from the note. I'm not finding anything. I'm not calculating anything. 1 billion in the year 2013, 1.35, 2.6, 2.7, 2.6, 2.7, 3, 3.3, 3.7. Okay. So we have all of our data, right, starting from 2013 to 2022. What we're going to do is we're going to highlight our two columns. We're going to go insert, and we're going to go down to chart. Now we might be lucky enough, and it might create one for us right off the bat. However, in this case, it's created a line graph, which is okay, but we want a scatter plot. So we're going to go up over to chart type. It's already under setup. Drop down arrow, and it says scatter chart, right? If not, if we don't see a recommended one at the top, you can go down where it says scatter chart at the bottom. So here we have our data, right? Next thing we want to do, I clicked out of it. So if you ever click out of it, you can go back up to the three dots, edit chart. We're going to go to customize. We're going to go down to series. And we're going to scroll down to see where it says trend line, right? We see this little checkbox. So we're going to check that off. And as soon as we do that, it creates a line of best fit for us, which is what we want to do, right? We can adjust it if we want, right? Maybe make it dark, change how opaque it is, increase the size. We don't want to increase it too much, make it stand out a little bit more. Right? So you can always customize. You can also add data labels you want for each individual ones. We don't need that right now. But I have my line of best fit now. And the nice thing about using technology is that it creates the best line of best fit, and it's going to be the same for everyone. So as long as you entered in the same value, you're going to have the same line of best fit as everyone else. And it's going to be the best possible one that the technology can come up with. Now, the other thing we want to do, for down here when we're customizing where it says label, we want to say use equation. So now when we look up here, now we have a linear equation. We have an equation of this line of best fit, this y equals mx plus b, right? The slope and the starting value. Right? So we have our line now, so we can use this equation if we wanted to make predictions, and we are going to do that. The other thing we want to add, we want to show the r squared value. So we want to click off that checkbox. It's still in the customize option, and we get an r squared value that comes up here. Now we could just take the value as is and say, is it close to 1? In this case, it is. It is very close to 1, right? It's 0.963. You could also square root that to get the correlation coefficient. And when we square root it, we get 0.981. Right, so even closer to 1. Right, so this would mean that this line is a very good fit for our data. Right, it's a very strong fit. So if we go back, we'll bring it up when we look at a couple questions. Right, we want to say, okay, based on the information that was gathered, was the line of best fit good? Well, we can pop it back up, right, and we see that. Again, because of that r squared value and looking at the data, we could say that yes, it is a good fit. How do you know? Right? We could say, well, based on how we create a line of best fit, you could say it follows the trend, right? Is close to points. The main thing that we want to refer to is the r squared value, right? So the r, not r2, r squared value is 0.963. So this means that it is a strong correlation. So that means with the Lakers and their value, there's a strong correlation between the year and the value. So as the time increases, the value should be increasing. What is the expected value of the sports club after 20 years? So if I look at my graph only goes up to 8. So I can't really do anything with that. But the nice thing is I have an equation. I have y equals 0.518 x plus 1.01. So what I can do is this is telling me an x value, right, after 20 years. I can use this equation, I can use that line of best fit, right, and say y equals 0.518 times 20 plus 1.01. And when we go through and calculate, we get a value of 11.37. So that means in 20 years, the Lakers, based off of this model, therefore in 20 years, from 2013, I should say, in 20 years from 2013, the Lakers will be valued at $1.37 billion. So that's how we can use that line of best fit to make predictions. If I was going to use it normally without it, right? Say for example, I wanted to find out what is the value at say 9 years. Right? I would go over to 9 and I would go up and I would see, okay, where does my line touch? Right at 9. Well, it touches right here, so that's just below 6 billion. Right? So after 9 years, my model is saying I should be just below 6 billion. Obviously, 20 years isn't on this graph. Right, so we could extend it if we really wanted to, but we may not be accurate, right? I said the model says for 9 years it's about 6. I don't know the actual value. Using this equation up here that's given to us, we can actually go through and find the exact value that would be on that line for whatever value we wanted to predict. So depreciation, we're going to look at the same thing. Oops. We're going to look at the same thing, but for a used car over the last 5 years. So I'll let you try to do this one on your own, right? Because we can come up with any type of car model. But year 2022, that is going to be your year zero. Then you're going to find the model car in 2019 and write down the value. You're going to find it in 2018, write down the value, and so on. And then we're going to go through and we're going to do the same thing that we just did, but for depreciation instead of appreciation. And then we're going to use that to figure out, okay, if I bought the car in 2020, after 12 years, how much would it be worth? So again, I'll let you try that one on your own just because we don't have specific car data in class. We're going to collect that on our own. But the main thing is we did go through an example looking at creating scatter plots in Google Sheets. So again, I do recommend that you do try it, to practice it, get used to it, get comfortable with using Google Sheets, because that is something that you might might have to use later on, right? So it is a good skill to have, not just for math, but for life in general. The main thing, and again, aside from knowing how to make the graphs, understanding how we can tell if a line is good or a line of best fit is good, if it has the correlation or if it is going between the points, following the trends, things like that, and understanding how that R-squared value can help us determine if it is a good, strong correlation.